Hello students, let us solve the question from the chapter Rigid Body Dynamics. This is a certain region based question. So let us read what is the question. This is assertion and region based question. There is assertion and region. So what is the assertion? Given that the value of radius of gyration of a body depends on the axis of rotation, and the reason is radius of gyration is root mean square distance of particle of the body from the axis of rotation. So there are four options for this, so we have to choose what is the correct answer. So let us draw axis of rotation. This is the axis of rotation, and there are n number of, suppose there are n number of particles and all the particles are at different distance from this axis of rotation. So let us suppose particle 1 is at a distance r1 from this axis of rotation. Similarly, another particle is at a distance r2, third particle is r3, and so on for all other particles. This is distance for all the particles 1, 2, 3, 4, and we can suppose such number of particles. So this is the distance from the axis of rotation. This is the axis of rotation, and particles are at distance r1, r2, and so on. So first of all, the value of radius of gyration of a body depends on axis of rotation. This is correct, since this is the axis of rotation, and this distance from the axis of rotation is important for calculating the radius of gyration. So this distance is important, and from the axis of rotation this distance can be measured. So all the particles from the axis of rotation, this distance is important, and the axis of rotation, from only axis of rotation we can find the distance of the particles. So radius of gyration is depends on the axis of rotation. This statement is true, and to calculate the radius of gyration we can write there are n number of particles at a distance r1, r2, and r3, and so on. So a radius of gyration is denoted by capital K, and a square of the radius of gyration is given by the distance square, all the distances, and is square, r1 square, r2 square, r3 square, and to n number of terms, and all the terms are divided by the total number of particles. So there are n number of particles, we can divide n. So this is the square of the radius of gyration. So what we can write for the radius of gyration? Radius of gyration can be written as K, and it will have the term a square root of r1 square plus r2 square plus r3 square, and so on for n number of particles, and divided by n. So this is the radius of gyration, and this is, you can see, this is the square root of mean of a square of the distance. So this is the root, since this is the square root, we can have root mean of all the terms, root mean square. This is the square term, root mean square distance. So radius of gyration is the root mean square distance of the particle from the axis of rotation. So first assertion is correct as it depends on the axis of rotation, and the radius of gyration, as here you can see that this is the root mean square distance of the particle from the axis of rotation. So the reason is also correct as reason given, radius of gyration is root mean square distance of particle of the body from the axis of rotation. So this reason is also correct, and reason is the correct explanation of assertions. Why? Since the axis of rotation, from the axis of rotation we can measure the distance r1, r2, r3 and so on. So this reason is correct explanation of the assertion. So what is the correct answer? Both assertion and reason are true, and R is correct explanation of A. So option first, this option is correct answer. Reason is the correct explanation of assertion. So both assertion and reason are true, and reason is the correct explanation of assertion A. So this is the correct answer. Hope you found the solution understandable. Thank you.